So we often talk about the biomass of the forest. All that is how much do the trees weigh. If you know their biomass, how much they weigh, half of the biomass of a tree is carbon. Well, my name is Ralph Dabaya. I'm the principal investigator of the GEDI mission, and I'm a professor of geographical sciences at the University of Maryland. It's really critical that we understand what the current carbon content of forests is today. We need a good global map of where the carbon is. And the reason we need that is because whenever we cut down trees, we're going to release carbon into the atmosphere, and we don't know how much carbon we're releasing. GEDI will tell us how tall the trees are. By knowing how tall they are, we will know how much they weigh. By knowing how much they weigh, we will know how much carbon is being lost into the atmosphere.
So GEDI weighs about 1,000 pounds and looks about like a refrigerator. So it has a telescope that's about 80 centimeters in diameter, has 3 laser ports, and shoots out 4 laser beams that are then dithered really quickly in between shots. So it makes one laser look like 2. So I'm the instrument scientist for GEDI, and that's sort of the translator between the engineering and the science. So Ralph and I, we've been working on GEDI for over 20 years and trying to get the technology ready and the science ready, and so we could fly a mission like this. And it's been great to get to this point. Okay, so GEDI is a laser altimeter, so it's an active optical instrument. So we have lasers that emit pulses of light. They travel down to the Earth, they get reflected from the Earth, and then we receive the reflection. So we time how long it takes to get there, which allows us to measure the range to the surface. When the pulse of light hits the surface, it gets distorted and stretched out by any structure that's there.
It looks almost like an echocardiogram. It's a distorted Gaussian waveform, technically speaking, and where the amplitude of that waveform is bigger is where there's more canopy stuff. There's more leaves and branches at a particular height, and where the amplitude is smaller, there's less canopy material.
The overall goal of GEDI is to systematically and consistently sample the vertical structure of the world's forest, so we can estimate from that structure the carbon content of the forest.
Really, one of the coolest things about GEDI is that we're going to get upwards of 10 billion estimates at how tall trees are. It's highly likely that trees on your block are going to be measured by GEDI, and you'll be able to see how tall they are. We simply do not know how tall trees are globally. So this is really, really exciting and really cool. You can take your kids down the block and say, hey, GEDI measured that tree.